हेलो फ्रेंड्स, स्वागत है आपका मेरे चैनल में। आज मैं डिस्कस करने जा रहा हूँ लीटकोड प्रॉब्लम 2 ऑफ द वीकली चैलेंज 2368 रीचेबल नोड्स विद रिस्ट्रिक्शंस। चलिए पहले प्रॉब्लम को पढ़ते हैं। देयर इज एन अनडायरेक्टेड ट्री विद n नोड्स लेबल्ड फ्रॉम 0 to n-1 and n-1 edges. Okay, so 0 to n-1 nodes, so there are n nodes and there are n-1 edges, which is the property of a tree. Okay, and we are given in 2D integer array edges of length n-1, where edges of I denotes a of I comma b of I, mean which indicates there is an edge between a of I and b of I. So we are given an undirected tree. So if there is an edge between ai and ba, okay, so it's denoted by edges of I. And we are also given a restricted array which contains the restricted nodes, means that we can't go to that node. Okay, and we have to return the maximum number of nodes we can use from node 0 without visiting a restricted node. Okay, note that node 0 will not be restricted node. So they are clearly mentioned that the first node means the node 0 will not be a restricted node. So see, this is the first example which is given to us. Okay, and you can see that the edge is 0 comma 1, means that there is an edge between 0 to 1, 1 to 2, there is an edge between 1 to 2, and the red color highlighted is the restricted nodes 4 and 5. Okay, so let's check whether let's check the number of nodes which can be reached from 0, or you can see that the number of nodes we can reach without traveling the restricted node. So you can see that we can travel from 0 to 1 because there is given 0 to 1 edge, and from 1 you can go to 2 because there is an edge 1 to 2, and from 3 to 1 is an edge, so we can go from 3 to 1. But see that there is 0 to 4 is also an edge, but you can't go to 4 because it's in the restricted array. Okay, there is also edge between 0 to 5, but you can't go because 5 is a restricted one. But the main point is that there is an edge between 5 6, because you can see that if we can't go from 0 to 5, then we can't reach this node. Either it will be reachable, either it will be not restricted or restricted. So you can't reach 6 because because from 0 to 6 the node which came in between is 5 and it's in restricted node, so you can't reach this node. So the number of nodes which are reachable are marked in green, which is 0 1 2 3, and output is 4. Okay, now let's check out the second example. In second example they are saying that they have given us the 7 nodes and edges they have given us in a vector, and the restricted nodes are 4 to 1. Okay, you can see that there is edge between 0 to 1, but 1 is restricted, and there is edge between 0 to 2, but 2 is restricted, so it can't be reached. There is edge between 0 to 4, but it can't be reached because S4 is restricted. But there is edge between 0 to 5, and it can be traversed. And from 5 there is an edge between 6, which is given as 6 to 5, so it can be traversed. And there is an edge between 2 and 3, but 2 can't be reached, so 3 is also not reachable, either it's restricted or not. Okay, so number of nodes which are restricted are marked in green, which are 0 5 and 6. Okay, so let's check out how to approach this problem. Okay, so this is the first example that they have given to us. So this n equal to 7 means that the number of nodes, okay, and edges are given to us, and restricted is the array which can't be reached. So first we will make an adjacency list. Okay, let's make the adjacency list. The number of nodes are 6, so adjacency node will contain 7 nodes: 0 1 2 3 4, sorry, it's 4 5 and 6. Okay, so from 0 you can reach to 1, so it will be 1, and as it is undirected, so 1 from 1 you can reach to 0, this is also possible. And from 1 you can reach to 2, so it's like 2, and it's indirected, so 2 to 1 is also an edge, so 1. 3 to 1, from 3 to can reach to 1, and it's undirected, so 0 to 3 also exists, so 1 to 3 also exists. 4 to 0, so 0 to 4 correspondingly, and now 0 to 5, so this is also possible, so 5 to 6, then 6 to 5 is also there. So see, and the restricted nodes are 4 and 5. Okay, let's mark them so that it could be visible that these are the restricted nodes. So this is one of the restricted node, this is one of the restricted node. Okay, so see, we have made our adjacency list. This is our adjacency list, and now what we'll do is that we will perform the DFS algorithm. Okay, for performing the DFS algorithm, we'll maintain a visited array. Okay, we'll maintain a visited array, and visited array will contain the number of nodes. So it are 7 nodes, and starting from 0, so it will be, okay, let's name it from 0 to 6. 0, 1, 2, 3, 4, 5, and 6. Okay, so see, I've made a longer array and it could be small. So let's initialize all the nodes at 0 because all the nodes are not visited. All the nodes are not visited. And now by marking the 0, it's indicate that all the nodes are not visited. Okay, 0, 0. And we have given that the node 0 is not restricted, means the first node of the tree is not restricted. Okay, this they have said. So see, first what we will do is that the number of restricted nodes are this. So we'll mark the restricted nodes as 1. Okay, so we'll mark them as 1. Let's mark 4 and 5 as 1. It will be 1. It will be 1. Okay, and we'll perform from the 0th node DFS, and we'll check if the visited of the, and we'll check of the adjacency of 0. If the visited of the adjacency node of the 0 is not visited, then we'll perform the DFS. Else if it's visited, then we will not perform the DFS. And whenever the DFS function call is carried out, then we'll increment our counter, and counter will be initialized to 0 as a global variable. So it would be more clear when you will traverse this. So let's check out the example. Okay, so see, we'll start from the first node. Okay, so we'll mark this as 1, and the first node you can see that you can go to 1, you can go to 4, you can go to 5, and if you'll go to 1, then you can see that the visited of 0 visited of 1 is 0, so you can go there. Okay, then you will go there, and you will mark this as 1, and then go to adjacency of 1. Adjacency 1 contains 0, 2, and 3. 0 is already containing the 1, so it will not go there. 2 contains 2 does not contain 0, so it will go into 2. Okay, and from 2 you can only go to 1. Okay, 2 you can only go to 1, and 1 is already visited, so you'll backtrack, and from 1 you can go to 3. So 3 is also possible, and from 3 you can only go to 1. Okay, and because we have traversed the 4 nodes, so our counter will be 4. As whenever the DFS is called, we will increase our counter. C is 4. Okay, and now you can see that from 3 you can only reach to 1, so we'll backtrack. Okay, we have completed the first adjacency. Now you can go to 4, but you can see that the 4 is already wasted, as it is the restrict node, which I have marked with brown. And next node is 4, and this is also a restricted node because you can't reach there, so you will backtrack. And once you will finish all the iteration, then you will return the count. Okay, either you can return this, or you can use the number of ones which are present in the visited array. This is our visited array. Okay, number of 1 in visited. Okay, minus the restricted dot size. This is it contains the size which is 4 and 5, so it will be 2. So it will also give the number of nodes which are reachable. So this is the approach that will carry out. Now let's check out its code. So see, first I am maintaining a visited array, then maintain our adjacency list, and as it is undirected array, so it will be from e of I to 0 to till e of I till 1, and correspondingly e of I from 1 to e of I 0. Okay, and if it's directed array, then this will be ignored. Okay, it will not be there in the directed array. Okay, now we'll check out. We will mark the restricted array nodes with 1, wasted 1. This what I have done through this line. We will count the DFS. Okay, we have maintained a C which counts the number of nodes which are reachable, and first node is reachable. It is given in the question. So visited of node equal to 1 and C plus equal to 1, and then we traverse in the adjacency of the node, and we will check if it's not visited, then we will perform the DFS. Else if it's visited, then we will not perform any iteration of that node. Okay. Thank you friends. If you like the solution useful, then you like and share and subscribe to my channel. Please friends, like और शेयर करिए जिससे मेरा चैनल और ग्रो करे और मैं और अच्छे अच्छे क्वेश्चन आपके लिए लेकर आऊँ.